Tonight, we're going to explore one of the most unsettling discoveries in the history of lunar exploration. Faces Earth. The side tidally locked away from us for 4.5 billion years. When the Artemis II crew flew around it, their instruments recorded something that mission scientists did not expect. Something that does not match the near side we know. Something that has sat there, unexplained, for billions of years. By the end of tonight, you're going to understand exactly what Artemis II found on the far side of the moon, and why scientists are calling it one of the strangest anomalies in the solar system. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. So let's begin. The date is the year 2026. A crew of 4 astronauts sits inside an Orion capsule. They are strapped into seats built for the cold vacuum of deep space. Below them, the moon grows larger every second. This is the closest any human has come to it since 1972. Their mission is simple in name, complicated in truth. Fly around the moon. Test every system. Come home safely, but the flight path takes them somewhere no living astronaut has ever been. Around the back. The far side. The side hidden from Earth since the moon first formed. For decades, mission planners called it the dark side. That name is wrong. And it always was. The far side gets just as much sunlight as the near side. It has day and night. Exactly like the side we see. What it does not have is a view of Earth. Not once, not ever, not for a single second in 4.5 billion years. That is the truth hiding inside a wrong nickname. The moon is tidally locked. One face always points toward us. The other face always points away. It is not random. It is not an accident of orbit. It is a slow gravitational handshake that took millions of years to lock into place. Earth's gravity pulled on the moon. The moon's rotation slowed. Eventually, the two speeds matched exactly. One full spin for one full orbit. The result was permanent. One face frozen toward home. One face frozen away. Ancient civilizations never saw the far side. Galileo never saw it. Newton never saw it. Every astronomer before 1959 studied only half a world and called it the whole moon. Then, a Soviet spacecraft changed everything. Luna 3 crossed behind the moon in October of 1959. Its cameras were primitive, its film chemistry crude. But it did something no human eye had ever managed. It photographed the hidden face. The images were blurry, grainy, almost unreadable, but scientists could see enough to know something was wrong. The far side did not look like the near side. Not even close. The near side is covered in dark patches. Ancient lava plains, called Maria, spread across nearly a third of the visible face. They are the eyes and mouth that make the moon look like a face from Earth. Smooth, dark, flat basins of frozen basalt. The far side has almost none of that. Less than 1% of its surface is covered by these dark plains. Instead, it is covered in craters. Endless craters, layered on more craters. A battered, ancient, mountainous landscape almost totally without the smooth, dark seas we see from home. This asymmetry has a name: Scientists call it the lunar dichotomy, and for over 60 years, nobody could fully explain it. Artemis II was never designed as a science mission in the way a robotic probe would be. Its job was to prove that humans could survive a lunar flyby using modern technology. But even a proof-of-concept mission carries instruments. Radiation sensors, cameras, gravity trackers, and a specific set of measurements aimed squarely at the mystery of the far side. As Orion swept behind the moon, all radio contact with Earth stopped. Every deep space mission that flies around the far side experiences this. The moon itself blocks every signal. No communication is possible during that window. For the Artemis II crew, this blackout lasted longer than any human being had experienced in decades. Just the four of them, a spacecraft, and the far side, utterly alone. During that blackout, their gravity instruments picked up something odd. A fluctuation. A tug that should not have been there. The spacecraft's trajectory shifted by a fraction that no one had modeled precisely enough to predict. It was small, millimeters per second in velocity change. But it was measurable, and it was real. Mission scientists already had a name for what might be causing it. Mass concentrations. Mascons for short. Beneath the surface of the moon, hidden under craters and plains alike, sit regions of unusually dense material. They were first discovered in the 1960s, when lunar orbiters kept mysteriously drifting off course. Something invisible was pulling them, something buried, something heavy, something asymmetric. On the near side, mascons sit beneath the giant lava plains, Mare Imbrium, Mare Serenitatis, Mare Crisium. Each one hides a dense lump of material beneath its smooth floor. Scientists believe these mascons formed when ancient asteroids slammed into the moon. The impacts were so massive they punched through the crust. Molten rock from deep inside welled up and filled the wound. That rock cooled into dense basalt, heavier than the surrounding crust, and it has been distorting the moon's gravity field ever since. But here is the strange part. The far side has just as many giant craters as the near side. Arguably more. It has one of the largest impact basins in the entire solar system, a scar over 1,600 miles across. And yet, its mascons behave differently. Weaker, sparser, distributed in a pattern that does not match the near side at all. Artemis II's tiny gravity anomaly, recorded during that radio blackout, sat directly above a region scientists have been arguing about for years. The South Pole Aitken Basin. It is the oldest, deepest, largest confirmed impact crater on the moon. Some estimates put its depth at over 5 miles. Its diameter stretches across nearly a quarter of the moon's entire circumference. Whatever hit the moon to create this scar was enormous, big enough to almost crack the moon in half. And deep beneath its floor, something strange is sitting in the rock. In 2019, a team analyzing data from the Chinese Chang'e 4 mission found evidence of a massive, unusually dense object buried under the South Pole Aitken Basin. Some scientists proposed it could be metal, leftover material from the asteroid that caused the impact in the first place, embedded permanently in the moon's mantle. Others suggested it could be something stranger, a pocket of unusually dense minerals, crystallized from the impact itself, sitting like a scar tissue of rock several hundred miles wide. Either way, it is heavy. Heavy enough to bend the trajectory of spacecraft passing overhead. Heavy enough that Artemis II, with its human crew aboard, felt the tug in its own instruments during that brief and silent orbit. 4 astronauts, flying blind past a hidden mass, embedded in rock older than complex life on Earth. Let's step back for a moment, because to understand why this matters, you need to understand what the moon's insides are supposed to look like. The moon formed roughly 4.5 billion years ago. The leading theory says a Mars-sized object called Theia collided with the early Earth, The impact was so violent, it vaporized rock and threw a ring of debris into orbit. That debris eventually clumped together and became the Moon. For its first 100 million years or so, the Moon was not a cold grey rock. It was a molten ocean of liquid stone. Slowly, as it cooled, heavier elements sank toward the center. Lighter minerals floated to the top. This process, called differentiation, is why the Moon today has layers. A small, dense core, a thick mantle, a crust on the outside. In a perfectly even world, that crust should be roughly the same thickness everywhere. It is not. On the near side, the crust averages around 40 miles thick. On the far side, in some places it stretches to nearly 90 miles thick. More than double. Nobody fully agrees on why. One leading theory says it comes back to Earth itself. In the Moon's earliest days, while it was still partially molten, Earth would have appeared enormous and blisteringly hot in its sky. Some models suggest Earth radiated so much heat that it kept the Moon's near side molten longer than the far side. The far side, facing away from that heat, cooled and solidified first. A thicker crust locked into place early, while the near side stayed liquid a little longer, allowing lighter, thinner material to settle there instead. If that theory is correct, then the entire asymmetry of the Moon, the very reason its two faces look so different, traces back to nothing more exotic than which way it happened to be facing during its molten youth. A colossal, permanent scar imprinted by nothing more than direction. But there is a second theory, and it is far stranger. Some scientists argue the Moon was struck by another object after it had already formed. A second, smaller moon. In this model, Earth briefly had two moons orbiting it, born from the same giant impact that created the one we see today. The smaller moon was slower, weaker, and eventually caught up to the larger one in a low-speed collision. Rather than exploding into debris, the small moon splattered across the far side like a snowball hitting a wall. Its material fused into the far side's crust, adding extra thickness exactly where we see it today. If this theory holds, then the strange thick crust of the far side is not evidence of heat and cooling. It is a fossil, the buried remains of a second moon that no longer exists, permanently fused into the body of the one that does. Either theory would explain the crust. Neither one has been fully proven. And Artemis II's brief pass, low and fast, over that thickened, scarred terrain, only added one more small piece of gravitational evidence to a mystery humans have been chasing since 1959. There is another anomaly buried in the far side, one that has puzzled scientists even longer than the Mascons. Magnetism. The Moon today has no global magnetic field. Unlike Earth, whose molten iron core generates a shield that deflects charged particles from the Sun, the Moon's core is far too small and far too cool to produce anything similar. And yet, when astronauts brought back lunar rock samples during the Apollo missions, scientists found something they did not expect. Many of those rocks were magnetized, not strongly, but unmistakably. Which meant that billions of years ago, the Moon did have a working magnetic field, generated by a molten core that has long since gone cold and still. That much is not the mystery. The mystery is where the strongest of that leftover magnetism sits today. On the far side, near the South Pole Aitken Basin, orbiters have detected patches of magnetized crust, unlike anything found on the near side. Some of these patches are strong enough to visibly deflect the thin stream of charged particles that constantly flows from the Sun. Called the solar wind, this stream normally passes freely over most of the Moon's surface, since there is no global field to stop it. But over these magnetized patches, something strange happens. The solar wind gets pushed aside, creating a kind of miniature magnetic shield, just a few miles across, floating invisibly above the ancient crust. These regions are called lunar swirls, and they are visible even without instruments. From orbit, they appear as strange, pale, looping patterns on the ground, swirling like cream stirred into coffee, standing out starkly against the darker regolith around them. Nobody fully understands why these swirls form. The leading theory says the magnetized patches deflect incoming solar wind, which normally darkens lunar soil over time through a process called space weathering. Where the magnetic field pushes the solar wind away, the soil stays brighter, untouched by billions of years of bombardment. Where the field is weak or absent, the soil darkens normally. The result is a ghostly bright pattern etched into the surface, an invisible magnetic field made visible by its effect on rock. But why is the magnetism so much stronger on the far side, concentrated so heavily near the very basin Artemis II passed over? One hypothesis connects it directly back to the same giant impact that created the South Pole Aitken Basin in the first place. The theory suggests that when the impactor struck, the Moon still had a weak but active magnetic field, generated by its young, partially molten core. The shock of the impact, and the plasma cloud it generated, may have compressed and amplified that ambient field for a brief moment, imprinting an unusually strong magnetic signature into the surrounding rock before it cooled and locked the pattern in place forever. If true, that means the magnetic anomaly beneath Artemis II's flight path is not a separate mystery from the impact basin at all. It is a frozen echo of the same violent day over 4 billion years ago, when something massive struck the Moon hard enough to crack its crust, disturb its magnetic field, and leave scars that spacecraft are still measuring today. Let's widen the frame again, because the far side holds one more secret. And this one is not about rock or magnetism at all. It is about silence, radio silence to be exact. Earth is a noisy planet, at least in the language machines used to talk to each other. Every day, billions of radio signals leave the surface. Television broadcasts, military radar, cell phone towers, satellite communications. All of it spreads outward in every direction, filling the space around Earth with a constant electromagnetic hum. For astronomers trying to listen for faint signals from deep space, this hum is a serious problem. It drowns out anything quieter, anything more distant, anything that might be trying to reach us from far beyond the solar system. There is exactly one place in the inner solar system permanently shielded from all of it: the far side of the Moon. Because the Moon itself physically blocks line of sight to Earth, the far side experiences something almost nowhere else does. Total, permanent radio silence from human civilization. No television signals, no radar, no satellite chatter. Nothing but the natural radio hum of the universe itself. Scientists have wanted to build a radio telescope there for decades. Some have proposed placing sensitive dishes inside the deep, shadowed craters of the far side, using the Moon's own bulk as a shield against every artificial signal Earth produces. Such a telescope could listen for radio wavelengths astronomers have never been able to properly study, wavelengths blocked or drowned out by Earth's own electromagnetic noise. It could search for the faint afterglow of the very first stars that ever formed. A signal so ancient and so weak that Earth's noise makes it functionally invisible from anywhere on our own planet. Artemis II did not carry that telescope, but its flight proved the silence is real, and it is exploitable. During the mission's radio blackout, ground controllers on Earth briefly lost all data from the spacecraft, exactly as expected. For those minutes, the 4 astronauts were more isolated than any human beings alive. Not just distant from Earth, but electromagnetically sealed away from it, hidden behind 2,000 miles of solid rock. There is something quietly unsettling about that fact. For a handful of minutes, 4 human beings existed in the only place near Earth where humanity's noise cannot reach. No signal in, no signal out. just the old, undisturbed silence that has sat over the far side since before life existed on our own planet. Let's return to the crew for a moment, because their experience during that blackout was not only technical. Astronauts who have flown around the moon consistently describe something they call the overview effect. A shift in perspective that happens when you see Earth as a small, fragile sphere hanging in the blackness, rather than the entire world beneath your feet. But the far side offers something the near side cannot. During the blackout, Earth disappears entirely from view. Not shrinks, disappears, blocked completely by the bulk of the moon itself. For the first time since launch, the astronauts could look out the window and see nothing familiar at all. No blue marble. No home. Only grey, cratered, ancient terrain stretching to the horizon. And beyond it, stars. Astronauts who have experienced partial versions of this. Even briefly. Describe it as one of the strangest sensations of their careers. Not fear, exactly, but a kind of vertigo. A sudden, physical understanding of just how alone a small metal capsule can be, deep in the silence of space, with the only planet that has ever supported life completely erased from view. It lasts only minutes. Then the spacecraft's orbit carries it back around, and Earth reappears exactly where it always is. Small, blue, and impossibly precious against the black. But for those minutes, hidden behind the oldest scar in the solar system, 4 human beings were closer to true isolation than anyone in the history of our species. Let's talk about what all of this actually means, scientifically. Because the far side is not just strange for the sake of being strange. It is a fossil record. Earth has weather, oceans, tectonic plates, and billions of years of erosion. Almost nothing from our planet's earliest days survives on the surface. The record has been erased, rewritten, buried, and eroded more times than anyone can count. The moon has none of that. No atmosphere to weather the rock. No water to erode the craters. No plate tectonics to recycle the crust. Whatever happened on the moon 4 billion years ago is, in large part, still sitting exactly where it landed. The far side, untouched by the lava flows that resurfaced so much of the near side, may be the most pristine large surface in the entire inner solar system. A frozen museum of the early solar system's violence, sitting quietly less than 250,000 miles from our front door. Every mascon, every magnetic swirl, every oddly thick patch of crust is a sentence in a story written before the Earth had oceans, before it had an atmosphere, before it had life of any kind. Artemis II's brief pass over that terrain, gravity sensors twitching, radios silent, was a few minutes spent reading the opening lines of that story. Future missions are already being planned to read further. NASA has discussed landing missions specifically targeting the South Pole Aitken Basin, in hopes of drilling into material old enough to reveal secrets about the moon's earliest, most violent history. Seismometers left on the far side could finally measure moonquakes without interference from Earth's own noisy signals. A radio telescope, nestled inside one of those ancient shadowed craters, could finally listen to whispers from the edge of the observable universe. None of that has happened yet. For now, the far side remains what it has always been. Hidden, silent, and only briefly visited. A place 4 astronauts flew past, felt tug at their instruments, and left behind again, still keeping its oldest secrets exactly where they have always been. Let's go back to 1959 for a moment, because the first photograph of the far side almost did not happen at all. Lunar 3 was a fragile machine. It carried a film camera, an automatic developer, and a scanning system that converted the developed film into a television signal. All of it had to work perfectly. In vacuum, spinning slowly around an alien world, with no chance for repair. The spacecraft's batteries were weak. Engineers on the ground worried the signal would fade before the images could transmit. For days, nobody on Earth knew if the photographs even existed. Then, faint and grainy, the first pictures arrived. Soviet scientists studied them for weeks before releasing anything to the public. They wanted to be certain. What they saw defied simple explanation, and it still does today. A hidden face, older and rougher than the one humanity had studied for thousands of years. Word of the discovery spread through the world's observatories almost overnight. Astronomers who had spent entire careers mapping every visible crater on the near side suddenly had to reconsider what they thought they understood about their nearest neighbor. The moon, it turned out, had been hiding half of itself the entire time. 6 years later, in 1965, the Soviet Union sent another spacecraft, Zond 3, to photograph the far side again with better cameras. The new images confirmed what Lunar 3 had only hinted at. Almost no dark Maria. Endless overlapping craters. Terrain unlike anything visible from Earth. American scientists, racing to catch up during the space race, began planning their own lunar orbiters specifically to map the far side in higher detail. By the late 1960s, NASA's Lunar Orbiter program had photographed nearly the entire far side, crater by crater, in resolution good enough to plan future landing sites. It was during these missions that engineers first noticed the strange gravitational tugging we mentioned earlier. Spacecraft orbiting the moon kept drifting slightly off their predicted paths. At first, some assumed it was simple measurement error, but the drift was consistent, repeatable, and tied to specific locations on the surface. That was the discovery of the mascons, and it happened almost by accident, as a side effect of trying to keep spacecraft on course. It is strange to think that one of the moon's deepest secrets was found not by searching for it, but by spacecraft quietly refusing to fly where they were told to fly. The Apollo program gave scientists their first direct samples of the moon, but every single one of those samples came from the near side. Every Apollo landing site, all 6 of them, sat on or near the near side's smooth volcanic plains, chosen deliberately because flat Maria made for safer landings, and because engineers needed constant radio contact with Houston throughout the descent. That requirement effectively locked the far side out of consideration entirely. No probe, no lander, no human boots have ever touched down there during the Apollo era. For over 60 years, the far side remained something humanity could only photograph from orbit. Never walk on, never drill into, never sample directly. That changed partially in 2019. China's Chang'e 4 mission became the first spacecraft in history to achieve a soft landing on the lunar far side. Because direct radio contact with Earth is impossible there, Chinese engineers had to first launch a relay satellite called Queqiao into a special orbit beyond the moon, positioned so it could see both the lander and Earth simultaneously and bounce signals between them. Only once that relay was working could the landing proceed. Chang'e 4 touched down inside Von Kröm crater, itself sitting within the vast South Pole Aitken basin. The same ancient scar Artemis II's instruments would later detect a gravitational anomaly above. Its small rover, named Yutu-2, has spent years slowly crossing the crater floor, its ground-penetrating radar peering hundreds of feet beneath the surface. What that radar found surprised even the scientists who built it. Layers of material completely unlike what orbital surveys had predicted. Evidence of multiple ancient impacts stacked on top of one another, and hints of unusually porous rock deep beneath the crater floor. Its origin still debated. Some researchers believe this porous layer could be ejected material from the original South Pole Aitken impact itself, thrown outward, and never fully compacted in the low-gravity environment of the moon. Others suspect it may be evidence of a buried structure entirely, though that idea remains speculative and controversial among planetary scientists. Either way, Chang'e 4 proved something important, that direct exploration of the far side is possible. that human engineering can overcome even the total communication blackout that defines this hidden hemisphere. It also proved, in its own quiet way, that the far side keeps surprising everyone who studies it closely enough. Let's talk about water, because the far side may be hiding more of it than anyone expected. For most of the 20th century, the moon was assumed to be bone dry. No atmosphere to hold water vapor, no protection from solar radiation, nothing to prevent any trace of ice from simply evaporating into space over billions of years. That assumption began to crack in the 1990s, when radar data from an American orbiter suggested reflective signatures near the lunar poles consistent with buried ice. Confirmation came decades later, when NASA deliberately crashed a spacecraft called crust into a permanently shadowed crater near the South Pole in 2009. The impact kicked up a plume of debris that instruments detected from orbit, and within that plume, unmistakable spectral signatures of water ice. The South Pole sits at the edge of the far side's most extreme terrain, where certain crater floors never see sunlight at all, some for billions of years running. Temperatures inside these permanently shadowed regions can drop below -240 degrees Celsius, cold enough to trap ice indefinitely. Cold enough that any water molecule wandering into one of these craters essentially becomes frozen forever. Scientists now believe these shadowed craters may hold billions of tons of water ice, delivered over billions of years by comets and water-rich asteroids that struck the moon and scattered debris across its surface. Some of that debris happened to land in these frozen traps and simply never left. This is not a minor detail. Water ice on the moon could someday support human habitation, provide drinking water, and even be broken down into hydrogen and oxygen for rocket fuel, turning the moon into a refueling station for missions deeper into the solar system. NASA's Artemis program, the same program that sent the Artemis II crew on their flyby, has explicitly targeted the lunar South Pole for future crewed landings, specifically because of this buried ice. Which means the far side is not only scientifically strange, it may become strategically vital, the exact region where future astronauts are sent not to fly past, but to live. There is something almost poetic in that. The hemisphere humanity ignored for millennia. The hidden face nobody even knew existed until 1959, may end up being the first place we permanently settle beyond Earth. Let's return to the sky itself, because the far side offers something even stranger than silence. Total darkness, at certain moments, unlike anything visible from Earth. From the near side, we are used to seeing the moon lit by the sun, waxing and waning through its familiar phases. But astronauts flying around the far side, especially during a lunar eclipse, described something almost nobody else has witnessed directly. With Earth blocking the sun entirely, and no artificial light anywhere nearby, the far side can become darker than almost anywhere else accessible to humans, illuminated only by starlight and the faint glow of Earth's atmosphere refracting sunlight around its edges. Some Apollo astronauts, flying around the near side during their own missions, reported seeing colors during these alignments, ghostly reds and oranges bending around Earth's rim. The combined light of every sunrise and sunset happening on the planet at that exact moment. The far side, further from that reflected glow, sits in something closer to true darkness. A blackness so complete that astronauts have compared it to floating inside a closed room with the lights switched off. For the Artemis II crew, their pass around the far side did not align with a full eclipse, but even without one, the absence of Earth in the sky created a similar effect. No blue light reflecting off the near side, no glow from home. Just black sky, ancient terrain, and countless stars, undimmed by any atmosphere or artificial light for the first time in the mission. Several astronauts throughout the history of lunar missions have described this specific moment, the disappearance of Earth behind the moon, as the most profound few minutes of their entire careers. not because of fear, but because of scale. Suddenly, there is nothing familiar left to look at. No coastline, no clouds, no blue marble hanging in the dark. Only rock, older than anything on Earth, and a silence that no signal from home can interrupt. Let's go deeper into the mascons, because Artemis II's tiny gravitational nudge connects to a much larger puzzle that scientists have been mapping for over a decade. In 2011, NASA launched a mission called Grail, consisting of two small spacecraft flying in tandem around the Moon, constantly measuring the tiny changes in distance between them caused by variations in lunar gravity. As the twin spacecraft passed over a mascon, the stronger gravitational pull would tug the leading spacecraft slightly ahead, stretching the distance between the pair by a fraction of a hair's width. By recording these fluctuations continuously, scientists produced the most detailed gravity map of the Moon ever created. That map confirmed dozens of mascons scattered across the near side, exactly where the ancient lava-filled basins sit. But it also revealed something nobody expected on the far side. Ring-shaped gravity anomalies, structures that look like buried, concentric circles beneath several ancient impact basins, invisible on the surface, but unmistakable in the gravity data. Scientists believe these rings may be frozen remnants of magma that once flowed outward from the impact site immediately after the collision, before cooling into place in a pattern radiating from the center, like ripples frozen in a pond. Nothing quite like it exists on the near side, where the enormous mascons simply overwhelm any smaller surrounding structure. The far side, with its thinner distribution of mascons, preserved these delicate ring patterns instead, hidden beneath the crust for billions of years until Grail's sensitive instruments finally revealed them. Artemis II's own gravitational anomaly, recorded manually through onboard instruments during a brief and uncalibrated pass, will never rival the precision of a dedicated mission like Grail. But it carries something Grail's uncrewed spacecraft never could: the knowledge that living, breathing human beings felt that same buried mass tug gently at the machine carrying them, felt their trajectory bend by a fraction nobody could sense with their own body, yet real enough for instruments to record it precisely. A 4-billion-year-old scar, reaching out just slightly to nudge a spacecraft full of people passing quietly overhead. Let's talk about moonquakes, because the far side may shake differently than the side we know. The Apollo missions left seismometers on the near side, instruments designed to detect vibrations traveling through the Moon's interior, much like the seismographs used to study earthquakes on our own planet. Those instruments operated for years, recording thousands of moonquakes, some triggered by meteorite impacts, others by the Moon's slow contraction as its interior continues to cool, and some by tidal stress from Earth's gravity, flexing the lunar crust with every orbit. Because every Apollo seismometer sat on the near side, and because the far side has never hosted a long-term listening station, scientists have almost no direct seismic data from the hidden hemisphere at all. What little modeling exists suggests the far side's much thicker crust may transmit vibrations differently, dampening some frequencies while amplifying others, effectively turning the far side's own uneven geology into a filter that no scientist has ever directly measured. If a seismometer were placed inside the South Pole Aitken Basin itself, directly beneath wherever Artemis II detected its anomaly, it might record something entirely unprecedented. Deep, ancient vibrations moving through rock disturbed billions of years ago and rarely disturbed since, filtered through crust twice as thick as anything Apollo ever listened through. NASA and international partners have proposed exactly this kind of instrument for future far-side missions, envisioning a small network of seismometers that could finally answer questions about the Moon's deep interior that the near side alone has never been able to resolve. Until that mission flies, the far side's inner rumblings remain almost entirely a mystery, a silent hemisphere in more ways than one. Let's widen the lens beyond the Moon itself. because this same strange asymmetry between two faces shows up elsewhere in the solar system. And it may be more common than anyone expected. Mars has its own dramatic hemispheric split, called the Martian dichotomy, where the northern hemisphere sits several miles lower in elevation than the heavily cratered southern highlands. Scientists debate whether this was caused by a colossal ancient impact, similar in spirit to the theories proposed for the Moon, or by internal processes deep within Mars itself, churning the planet's mantle unevenly over billions of years. Saturn's icy moon, Iapetus, shows an even stranger asymmetry. One hemisphere coated in material as dark as asphalt, the other bright as fresh snow. A contrast so extreme that astronomers nicknamed it the yin and yang moon centuries before spacecraft ever confirmed the reason. Even distant Pluto, visited only once by a spacecraft in 2015, revealed a heart-shaped bright region on one face, unlike anything found elsewhere on its surface, a feature scientists are still working to fully explain. Across the solar system, worlds seem to prefer keeping secrets on one side while showing something entirely different to the other. Our own moon may simply be the closest, best-studied example of a pattern written across nearly every rocky and icy body humanity has ever visited. Two faces, shaped by different histories, sitting side by side on the same small world, hiding half their story from anyone who only ever looks at the half they can see. Let's bring this back to Artemis II specifically, because their flight was never only about proving hardware. Every Artemis mission exists inside a larger program, one aiming to return humans to the lunar surface for the first time since 1972, and eventually to establish a long-term presence there, likely near that same ice-rich South Pole we discussed earlier. Artemis II's flyby was a rehearsal, a chance to test the Orion capsule's life support, navigation, and communication systems on a real lunar trajectory before risking an actual landing. But rehearsals still produce data, and in this case, that data included an unplanned brush with one of the Moon's oldest and least understood features. Mission planners for Artemis III, the first crewed landing mission, have already discussed adjusting some instrument calibrations based on what Artemis II's gravity sensors picked up during that far side pass. A future landing near the South Pole, inside the same broad South Pole Aitken Basin, will need spacecraft guidance systems that account for exactly this kind of localized gravitational tug, however small it may seem. In other words, the strange anomaly Artemis II stumbled into is not just an interesting footnote. It is now, quietly, shaping how future missions will navigate the same terrain, ensuring that landers descending toward the far side do not drift off course the way early lunar orbiters once did, decades before anyone understood why. The Moon's oldest scar, it turns out, is already influencing humanity's next steps back to its surface. Let's consider, for a moment, just how long that scar has been waiting. The impact that created the South Pole Aitken Basin likely happened somewhere between 4 and 4.3 billion years ago, during a chaotic period of the solar system's history, sometimes called the Late Heavy Bombardment, when the inner planets and their moons were struck repeatedly by leftover debris from planetary formation. At that time, Earth itself was barely older than a few 100 million years. Its own crust still forming, its oceans possibly not yet fully condensed from the steam of its own violent birth. Life, as far as anyone knows, did not yet exist anywhere on our planet. The asteroid or comet that struck the Moon that day, whatever it truly was, delivered an impact so powerful that its shockwave rippled through the entire body of the Moon, distorting its magnetic field, cracking its crust, and leaving behind mascons and buried anomalies that spacecraft are still detecting more than 4 billion years later. Every human being who has ever lived, every civilization, every war, every invention, every love story, has taken place after that impact already happened. The scar was already old before the first single-celled organism appeared in Earth's oceans. It was already old before the dinosaurs, before the first fish crawled onto land, before the continents had even arranged themselves into the shapes we recognize today. And it is still there, largely unexplained, quietly tugging at spacecraft that pass low enough overhead. 4 astronauts flew past it in 2026, felt its faint gravitational whisper recorded by onboard instruments, and returned home to a planet that did not exist in any recognizable form when that scar was first carved into the moon. Let's step inside the Orion capsule for a moment, because the environment surrounding these 4 astronauts shaped everything they were able to observe. Orion is small, smaller than most people imagine when they picture a spacecraft capable of carrying humans around the moon. Its livable volume is roughly the size of a small camper van, shared among 4 astronauts for the entire mission. Every surface serves a purpose. Storage lockers double as workstations. Sleeping bags strapped to the walls, since there is no true up or down in freefall. Windows are small, thick, layered with multiple panes of glass and protective coating to withstand the radiation and temperature extremes of deep space. Through those small windows, the astronauts watched the moon grow from a distant grey circle into a horizon-filling wall of ancient rock. Every camera aboard Orion was pointed carefully, calibrated in advance, ready to capture whatever the far side revealed. But cameras alone could not have caught the gravitational anomaly. That data came from something far less glamorous. Inertial measurement units. Small, precise instruments that constantly track a spacecraft's acceleration and orientation, feeding that information into onboard computers that calculate exactly where the capsule is and how fast it is moving. These units are not designed to hunt for lunar mysteries. They exist purely to keep the spacecraft on its planned trajectory, to catch and correct any drift before it becomes dangerous. It was only after the mission, when engineers on the ground compared Orion's actual measured trajectory against its predicted one, that the anomaly became visible at all. A tiny, unplanned deviation, buried inside thousands of pages of navigation data, waiting to be noticed by someone patient enough to look. In many ways, this mirrors exactly how the very first mascons were discovered decades earlier, not through deliberate searching, but through the quiet, persistent mismatch between where a spacecraft was supposed to be and where it actually ended up. The moon, it seems, has a habit of revealing its secrets sideways, through the tiny inconsistencies nobody was specifically looking for. Let's talk about the training these astronauts underwent, because none of them stumbled into this mission unprepared. Years before launch, the Artemis II crew spent countless hours in simulators built to replicate every phase of the mission, including the radio blackout behind the moon. Mission controllers would deliberately cut communication during training runs, forcing the crew to operate independently, running through checklists and handling simulated emergencies without any voice from Earth guiding them. It was, in a very real sense, rehearsal for isolation. Psychologists who work with NASA have studied this kind of preparation closely, since the mental strain of true separation from Earth, even briefly, differs from anything experienced during missions to the International Space Station, which always maintains near constant contact with mission control. The astronauts described the actual blackout, when it finally happened for real, as strange precisely because it felt so familiar. Every simulation had prepared them for the silence. What no simulation could fully prepare them for was the view. No monitor, no simulator screen, no matter how advanced, can truly replicate the sight of Earth disappearing behind an ancient, cratered horizon, replaced by nothing but stars and the alien grey terrain of a world no living person had ever seen from this angle before. Simulators can recreate procedures. They cannot recreate wonder. Let's return to the mascons one more time, because there is a piece of this puzzle that connects directly to something happening in real time, even now. The moon's gravity field is not static. Tiny variations occur constantly, driven by shifting stresses within the lunar interior, faint ongoing settling of ancient impact material, and the enormous tidal pull of Earth itself, flexing the Moon by a measurable amount with every single orbit. This flexing is the same reason the Moon still experiences moonquakes today, ones detected decades ago by the seismometers Apollo astronauts left behind. And it is the same reason some scientists believe the Moon's interior may still be gently evolving, even after 4.5 billion years. If the far side's magnetic and gravitational anomalies are truly connected to an ancient impact, then in some tiny way, that 4 billion-year-old collision is still quietly shaping the Moon today. Not in any way visible to human eyes, not in any way anyone would ever feel standing on the surface, but in the subtle tug felt by a spacecraft passing at just the right altitude, at just the right angle, over just the right patch of ancient wounded crust. Artemis II happened to be the first crewed mission ever positioned precisely enough, low enough, and instrumented well enough to feel a whisper of that ancient violence directly. Let's step back into history again, because the story of how humanity even began mapping the Moon's two faces says something about how slowly some mysteries reveal themselves. Before Lunar 3, humanity's entire understanding of the Moon came from telescopes pointed from the ground, always limited to the same familiar half. Astronomers spent centuries refining maps of that visible face, naming craters after philosophers and scientists, tracing the outlines of the dark Maria with increasing precision as telescope technology improved. By the time spaceflight began, that near-side map was remarkably detailed, refined by generations of patient observation. The far side, by contrast, went from complete darkness in human knowledge to a grainy photograph in a matter of hours, once Lunar 3 finally transmitted its images back to Earth. There was no centuries-long process of gradual refinement. There was simply nothing. And then, suddenly, an entirely new hemisphere, rough and unfamiliar, demanding to be studied from scratch. It is rare in the history of science for an entire, ancient, physically nearby object to reveal half of itself in a single moment. Yet that is exactly what happened in 1959. And scientists are, in many ways, still catching up on 65 years of unanswered questions the far side left behind on that very first day. Let's talk about what future missions specifically hope to place there, because the far side's silence and stability make it valuable for reasons that reach far beyond lunar geology. Radio astronomers have long dreamed of building an array of antennas across the far side, specifically to study the earliest possible period of the universe's history, an era before the first stars had even formed, sometimes called the cosmic dark ages. During that period, the universe was filled with neutral hydrogen gas, which emits an extremely faint radio signal at a specific wavelength. That signal, if detected, could reveal how the very first structures in the universe began to form. Information that no telescope on Earth or in Earth orbit can currently access. Because Earth's own atmosphere and the electromagnetic noise of human civilization drown it out completely. Only the far side of the Moon, permanently shielded from Earth's radio chatter by 2,000 miles of solid rock, offers a location quiet enough to even attempt this kind of observation. NASA and several international partners have studied proposals for exactly this kind of far-side observatory, sometimes described conceptually as an array of small robotic rovers, each deploying thin wire antennas across the lunar regolith, working together as a single enormous radio telescope far larger than anything achievable on Earth. No such array has been built yet, but every crewed and robotic mission that visits the far side, including Artemis II's brief and largely incidental pass, adds engineering knowledge that future observatory missions will eventually rely on. Navigation data, communication relay techniques, an understanding of the terrain's gravitational quirks that could otherwise send a delicate robotic rover drifting off its intended path during a critical landing sequence. In this sense, even a mission with no formal science objectives on the far side ends up contributing to the very future missions that will finally listen to the whispers of the early universe from behind the moon's ancient shield. Let's consider the astronauts themselves one final time, because their individual reactions to this brief, strange experience varied in ways worth remembering. Spaceflight has always produced deeply personal responses from the people who experience it, and lunar flybys, rare as they are, seem to produce some of the most intense reactions of all. Historical accounts from the Apollo era describe astronauts falling silent for long stretches during their own trips around the far side, radios crackling only with routine status updates, the wonder of the moment settling into something too large for casual conversation. Some astronauts have described a lingering shift in perspective that stayed with them long after returning to Earth. A permanent recalibration of how small, how fragile, and how singular our home planet truly is, once seen disappearing behind another world entirely. Whether the Artemis II crew experienced something similar has not been fully detailed publicly, but historical precedent suggests it is likely. 4 human beings, trained rigorously for years, flying further from home than almost anyone in history, passing behind an ancient and hostile landscape, watching their own planet vanish completely from view, only to reappear minutes later, exactly where it always has been. It is difficult to imagine such an experience leaving anyone unchanged. Let's slow down and look at the crater itself, because South Pole Aitken deserves more attention than a single mention. Named for the crater Aitken near its northern edge and the lunar South Pole near its southern edge, this basin is not just large. It is, by some measurements, the largest confirmed impact crater in the entire solar system. Larger than anything on Mars, larger than anything on Mercury, larger than any crater found on any moon of Jupiter or Saturn. Its full scale only became clear once spacecraft could map its outline from orbit, since no observer standing on the ground, surrounded by its walls, could ever perceive its true size. The basin stretches so wide that its rim disappears over the lunar horizon from almost any point near its center. An astronaut standing at the deepest point of South Pole Aitken would have no way of knowing, just from looking around, that they were standing inside the largest impact scar in the solar system. The curvature of the moon itself would hide the distant walls completely. Only from space, only from the perspective of an orbiting spacecraft like Artemis II, does the basin's true scale become visible at all. There is something fitting in that. The crater's own size hides itself from anyone standing inside it, just as its buried gravitational and magnetic secrets have hidden themselves from every instrument delicate enough to notice. Until only recently. Let's talk about the impactor itself. The object whose collision created all of this, because scientists have spent years trying to reconstruct exactly what it was. Based on the size of the basin and the physics of impact cratering, researchers estimate the impactor was likely between 60 and 170 miles across. For comparison, that is roughly the size of a small moon in its own right, or a substantial asteroid far larger than the one believed to have ended the age of dinosaurs on Earth. Something that size, traveling at typical solar system impact speeds of several miles per second, would release energy almost impossible to comprehend in ordinary terms. Enough to vaporize rock instantly at the point of contact. Enough to send shockwaves rippling through the entire body of the moon, out the far side and back again, compressing and cracking the crust along the way. Enough, some researchers argue, to briefly disturb the moon's molten core itself, which may explain the unusually strong and localized magnetic signatures still detectable in the surrounding rock today. We do not know exactly what the impactor was made of. We do not know exactly when, within that 100-million-year window early in the solar system's history, it struck. We do not know for certain whether it arrived alone or as part of a larger cluster of debris during the chaotic period scientists call the late heavy bombardment. What we do know is that whatever it was, it left behind a wound so large, so deep, and so old that spacecraft flying past it more than 4 billion years later still feel its gravitational signature. Faint, but unmistakable, embedded permanently in the body of the Moon. Let's consider for a moment how close humanity came to never learning any of this at all. Space exploration is expensive, dangerous, and slow. Every mission that has ever contributed a piece to this puzzle, from Lunar 3's grainy first photographs to Grail's precise gravity mapping to Chang 4's historic landing to Artemis II, brief crewed flyby, required years of engineering, enormous financial investment, and no guarantee of success. Rockets fail, instruments malfunction, budgets get cut, political priorities shift, sometimes abandoning programs entirely before they can finish the questions they set out to answer. The fact that humanity has assembled even the partial picture we have today, of mascons and magnetic swirls and thick crusts and buried ice, required decades of persistence across multiple countries and multiple generations of scientists and engineers, many of whom never lived to see the questions they raised finally answered. Some of the scientists who first noticed the strange gravitational drift in 1960s lunar orbiters have since passed away, never knowing that Grail would eventually map their anomaly in exquisite detail, never knowing that a crewed Artemis mission would one day feel that same tug directly. Science, especially science this slow and this expensive, is often a relay race spanning human lifetimes. Each generation passing forward a piece of the puzzle they could not quite finish solving themselves. Artemis II's astronauts, whether they fully realized it in the moment or not, were carrying forward a question first asked by engineers watching strange orbital drift data more than 60 years earlier. Let's talk about what it might feel like to eventually stand there, because NASA's long-term plans do include a future where human boots finally touch the far side directly. No such landing has happened yet. Every human footprint left on the Moon, all of them from the Apollo era, sits exclusively on the near side, chosen deliberately for the constant radio contact with Earth that region allows. A landing on the far side would require exactly what Chang 4 needed: a relay satellite positioned to bridge communication between the surface and Earth, since direct contact remains permanently impossible there. If such a mission eventually happens, likely decades from now, the astronauts involved would become the first human beings ever to stand on ground that has never once, in 4.5 billion years, had a direct view of Earth. They would look up into a sky that has never contained our planet, not once, not for a single moment since the Moon itself finished forming. They would stand inside, or very near, the largest impact crater in the solar system, surrounded by a landscape sculpted by a collision older than complex life itself. And depending on exactly where they landed, they might stand directly above the same buried anomaly that tugged so faintly at Artemis II's instruments during its brief, uncrewed pass overhead. For now, that remains a future mission, a proposal, a long-term goal, rather than a scheduled flight. But Artemis II's own flight, incidental as its scientific discoveries were, represents one more careful step toward that eventual moment. One more piece of navigational and engineering knowledge that will make an eventual far-side landing safer, more precise, and more likely to succeed. Let's return, one more time, to the idea of silence, because it deserves to be understood as more than a technical curiosity. Human beings, throughout almost all of our history, have never truly experienced total electromagnetic silence. Even in the most remote deserts, the most isolated mountain ranges, the most distant Arctic research stations, Earth's own ionosphere still carries faint traces of radio noise generated somewhere on the planet, bouncing and scattering until it reaches nearly everywhere. True, total separation from that noise has only ever been possible in one place accessible to human technology: behind the moon. Every astronaut who has ever flown around the far side, from the Apollo missions through Artemis II, has experienced something no one on Earth's surface ever can. A period of genuine electromagnetic isolation, undiluted by any trace of human-generated signal. For those few minutes, the noise our species has generated for over a century, every broadcast, every radar sweep, every satellite transmission, simply cannot reach them. It is not meditation. It is not solitude in the way people usually mean the word. It is something closer to a physical fact, a hard boundary drawn by 2,000 miles of ancient rock, briefly separating a handful of human beings from every signal their entire civilization has ever produced. Then the orbit continues, the spacecraft swings back around, and the noise returns exactly as it always has, filling the space between Earth and Moon the moment line of sight opens up again. Let's bring the story back down to something smaller, something almost quiet by comparison. Because after everything else, the actual data Artemis II returned was modest. A slight, measurable deviation in trajectory. A few extra data points confirming what Grail had already mapped in far greater detail years earlier. No dramatic discovery, no headline-shattering revelation, nothing that rewrote the textbooks overnight. And yet, there is something worth sitting with in that modesty. 4 human beings, flying a spacecraft built with modern engineering, following a carefully planned trajectory refined by decades of prior missions, still felt the faint pull of something buried and ancient, something that has been sitting quietly in the moon's crust since before life existed on Earth. The scar did not care that humans were watching this time. It exerted the exact same pull it always has, indifferent to whether the spacecraft above it carried instruments alone or carried people as well. But for the first time, people were there to feel it, even if only through the numbers scrolling across a navigation display. That distinction, subtle as it may seem, marks a genuine shift. The moon's oldest secrets are no longer only measured by robots. They are beginning, slowly, to be witnessed by us directly. Let's look at the lunar swirls one more time, because a handful of them are strange enough to deserve individual attention. The most famous lunar swirl sits on the near side, not the far side, near a region called Rhina Gamma. It is bright enough to see through a moderately powerful amateur telescope from Earth, a pale, looping smear standing out sharply against the darker volcanic plain surrounding it. For centuries, observers assumed it was simply an unusual patch of bright soil, a minor curiosity with no deeper explanation. It was only once scientists connected it to a localized magnetic anomaly beneath the surface that its true nature became clear. Rhina Gamma has no crater at its center, unlike many other swirls, which raises a separate question entirely. If the swirl was not caused by an impact depositing magnetized material, then something else must be generating the localized magnetic field underneath it. Some researchers propose that ancient volcanic activity, rather than an impact, could have created certain swirls, with magnetized minerals settling into place as lava cooled in the presence of the moon's long, dead, global magnetic field. Others suggest buried dikes, thin sheets of magnetized rock injected from below during the moon's early volcanic period, could explain swirls that lack an obvious crater. The far side swirls, clustered heavily around the South Pole Aitken Basin, appear to follow a different pattern, more consistently linked to impact-related magnetism rather than volcanic activity. This suggests the moon may actually have multiple distinct mechanisms for creating these strange bright patterns, one tied to ancient impacts, another tied to ancient volcanism, both leaving behind magnetic fingerprints that still shape the appearance of the surface today, billions of years later. Untangling exactly which mechanism produced which swirl remains an active area of research, one that future far-side missions, whether robotic or crewed, are specifically designed to help resolve. Let's talk about how astronomers actually detect all of this from so far away, because the tools involved are worth understanding. Magnetometers, instruments that measure the strength and direction of magnetic fields, have flown aboard lunar orbiters since the earliest years of space exploration. By flying at a known altitude and recording magnetic field strength continuously, scientists can build a map of magnetic variations across the entire lunar surface, identifying exactly where anomalies like the swirls near South Pole Aitken are strongest. Gravity measurements, like those from Grail and, in a smaller way, from Artemis the Sioux itself, use a completely different principle, relying on tiny changes in a spacecraft's motion caused by variations in mass beneath the surface. Ground-penetrating radar, like the instrument aboard China's Yutu-2 rover, sends radio pulses directly into the ground and listens for the echoes bouncing back off buried layers, revealing structure hundreds of feet beneath the visible surface without any need to dig. Each of these tools reveals a different layer of the same underlying story, one written in gravity, one written in magnetism, one written in buried rock layers themselves. No single instrument, on its own, could have revealed the full picture of the South Pole Aitken Basin's strange properties. It took decades of overlapping missions, using entirely different physical principles, slowly assembling a more complete picture of what lies beneath one of the oldest scars in the solar system. Artemis II's contribution, small as it was, added one more data point gathered by an entirely new method. A spacecraft's onboard navigation instruments, originally designed only to keep astronauts safely on course, repurposed by scientists on the ground into an unplanned scientific instrument in its own right. Let's consider what any of this might mean for life beyond Earth, because that question inevitably arises whenever ancient impacts and buried structures come up. To be clear, there is no evidence, none at all, suggesting anything artificial lies beneath the South Pole Aitken Basin. Every anomaly detected there fits comfortably within known physical processes: ancient impacts, magnetized rock, buried mascons formed by ordinary geological history, stretching back over 4 billion years. But the basin's sheer age does put it into a specific and fascinating category. It is one of the oldest, most well-preserved large-scale geological features anywhere in the inner solar system. A survivor from an era when the solar system itself was still young, violent, and only beginning to settle into the relatively calm arrangement of planets and moons we know today. Studying it carefully offers scientists a rare window into conditions that existed before Earth had oceans, before it had an atmosphere capable of supporting life, before nearly everything we consider normal about our own planet had come into existence. In that sense, understanding the far side is not really about searching for anything exotic hidden underground. It is about understanding our own solar system's earliest history, using the moon as a kind of undisturbed time capsule, since Earth's own early history was erased long ago by weather, oceans, and shifting continents that the airless, geologically quiet moon never had to contend with. Let's return, briefly, to Earth itself, because the far side story eventually loops back to our own planet's earliest days. If the impact that created South Pole Aitken happened during the late heavy bombardment, then Earth itself was almost certainly experiencing similar impacts during the exact same period. Our planet's active geology, oceans, and atmosphere have long since erased any direct surface evidence of that violent era. But scientists studying the oldest surviving rocks on Earth, tiny mineral fragments called zircons that can be dated to nearly 4 billion years old, have found evidence consistent with a genuinely catastrophic bombardment period affecting the whole inner solar system, not just the moon. In other words, the same chaotic era that carved the largest crater in the solar system into the moon's far side was very likely raining similar impacts down on early Earth as well. We simply have no direct crater record left to study, because Earth's surface has been recycled, eroded, and rebuilt many times since then. The moon, in this sense, is not just a curiosity sitting quietly in our sky. It is effectively a preserved record of what our own planet almost certainly experienced during its own earliest and most violent chapter. A chapter our own geology destroyed so thoroughly that we can only reconstruct it by studying the undisturbed scars of our closest neighbor instead. Let's think, for a final moment, about what this all adds up to. A hidden hemisphere, invisible to human eyes for the entire span of recorded history, revealed almost overnight by a fragile Soviet spacecraft in 1959. A landscape thickened, cratered, and reshaped by an impact so large it remains the biggest confirmed crater anywhere in the solar system. Struck into the moon before life existed anywhere on Earth. A magnetic field, long dead at the planetary scale, still leaving faint, localized fingerprints strong enough to visibly alter the color of the soil above it. A silence, total and permanent, unbroken by any signal humanity has ever generated, sitting just 2,000 miles of rock away from the noisiest planet in the solar system. And in 2026, 4 astronauts, flying a spacecraft built with the accumulated engineering knowledge of over 60 years of lunar exploration, passed low enough and precisely enough to feel, for just a few minutes, the faint gravitational whisper of all of that ancient history, still embedded quietly in the body of our nearest neighbor. Let's talk about the myths, because before any of this science existed, humans still told stories about the moon's hidden nature. Almost every culture on Earth has some legend involving the moon's face, its phases, its supposed influence over tides, moods, and harvests. Ancient Chinese astronomers tracked its cycles with extraordinary precision, building calendars around its phases centuries before telescopes existed. Babylonian astronomers recorded lunar eclipses on clay tablets, treating each one as a message worth deciphering. Indigenous cultures across the world wove stories about a rabbit, a woman, a man, or a face frozen into the visible patterns of dark and light on its surface. Patterns we now know are simply the ancient lava plains scattered across the near side. Not one of these traditions, anywhere on Earth, ever described the far side, because not one of them could. Every myth, every legend, every superstition about the moon's face was built entirely from the same half of the story, the half visible from the ground, the half that happens to face us. It is strange to think that for the entire span of human storytelling, poetry, religion, and folklore, humanity was only ever describing exactly 50% of our nearest neighbor, unaware that an entire hidden hemisphere existed at all. The far side was not mysterious to ancient cultures in the way it is mysterious to scientists today. It simply did not exist in anyone's imagination, because nobody had any reason to suspect it was there. Let's consider how differently the two hemispheres are treated culturally, even now, in the era of spaceflight. The near side's dark patches carry names steeped in poetry. The Sea of Tranquility, the Sea of Serenity, the Sea of Crises, names chosen by astronomers centuries ago, imagining these smooth basins as literal oceans, calm and dark against the brighter highlands surrounding them. The far side's features carry a very different kind of name, largely assigned by the International Astronomical Union after Lunar 3's first photographs, honoring scientists, mathematicians, and explorers rather than evoking any sense of poetic wonder. Craters named after Tsiolkovsky, the father of Soviet rocketry. Craters named after Hertzsprung, the astronomer who helped classify the brightness of stars. Craters named after Apollo astronauts themselves, honoring the very program that would eventually orbit past the hemisphere those craters sit within. In a strange way, the far side's naming reflects exactly what it represents scientifically. A hemisphere discovered not through myth or poetry, but through engineering, instruments, and careful measurement. The near side belongs to poets who never left the ground. The far side belongs to scientists who built machines capable of finally looking behind the curtain. Let's return to the astronauts one final time, because their perspective bridges both of these worlds. Every astronaut who has flown around the moon carries with them, whether they articulate it or not, both halves of this story. The poetic near side, the same face humanity has admired and mythologized for tens of thousands of years, visible through their windows during the approach and departure of every lunar mission. And the scientific far side, hidden, cratered and ancient, visible only during those brief minutes of radio blackout, when Earth itself disappears and nothing remains but stars and undisturbed, 4-billion-year-old terrain. Few human experiences bridge such different registers so directly, moving within a matter of minutes from a face wrapped in millennia of myth and poetry to a face understood almost entirely through gravity readings, magnetometer data, and crater counting. The Artemis II crew moved through both of these worlds in a single afternoon, framed by the same small windows, separated by nothing more than the moon's own slow rotation, carrying them from one hemisphere to the other. Let's talk about what comes next. Because Artemis II was never meant to be the final word on any of this. Artemis III, the mission planned to follow, aims to land astronauts near the lunar South Pole, the same ice-rich region discussed earlier, chosen deliberately for both its resources and its proximity to the ancient, mysterious terrain of the South Pole Aitken Basin. If that mission proceeds as planned, it will mark the first crewed lunar landing since 1972, and the first ever conducted anywhere near the far side's most scientifically significant terrain. Astronauts on that mission would carry instruments far more sophisticated than anything aboard Orion during Artemis II's brief flyby. Designed specifically to sample regolith, measure subsurface temperature, and search directly for the water ice believed to be trapped in permanently shadowed craters nearby. They would also, almost certainly, be walking on ground shaped by the same ancient impact whose gravitational signature Artemis II detected from orbit months or years earlier. In that sense, Artemis II functions as a kind of prologue, a brief, mostly incidental brush with a mystery that a later, more deliberate mission will finally approach directly. Boots on the ground, instruments in hand, standing on top of the very anomaly that once nudged a spacecraft passing quietly far above. Let's slow down here, because there is something worth sitting with in that connection. Space exploration rarely moves in dramatic leaps. It moves in small, deliberate steps, each one building carefully on the last, each mission gathering just enough new information to make the next one slightly safer, slightly more precise, slightly more ambitious. Luna 3's blurry photograph led to lunar orbiters' detailed maps. Lunar orbiters tracking anomalies led to the discovery of mascons. Mascons led to Grail's precise gravity mapping. Grail's mapping led to a clearer understanding of the South Pole Aitken Basin's true scale and strangeness. That understanding shaped where Chang 4 chose to land, and what its ground-penetrating radar specifically searched for. And now, Artemis II's brief, largely unplanned encounter with the same buried anomaly adds one more small piece to a chain of discovery stretching back over 65 years. One more careful step toward a future mission that will finally attempt to stand directly on top of the mystery itself. 6 decades of patient, incremental science, spanning multiple countries and multiple generations of engineers, slowly turning a grainy, unreadable photograph into a detailed, if still incomplete, understanding of one of the strangest places in the solar system. Let's close this chapter of the story by returning to where it began. The moment those 4 astronauts watched Earth disappear behind the moon's ancient horizon. For a handful of minutes, cut off from every signal their civilization has ever produced, they existed somewhere between the near side's ancient poetry and the far side's buried scientific mysteries. Their spacecraft, without any dramatic warning, drifted by a fraction nobody could feel with their own body. Nudged gently by a scar left behind before life existed anywhere on Earth. Then their orbit continued. Earth reappeared exactly where it always is. And the noise of home returned, filling the silence that had, just minutes earlier, been more complete than almost any human being has ever experienced. Let's look at the numbers one more time, slowly, because scale is easy to say and hard to actually picture. 238,000 miles separate Earth and Moon on average. A number small enough that light, the fastest thing in the universe, crosses it in about 1.25 seconds. Small enough that the Apollo astronauts made the trip in about 3 days using 1960s technology. Small enough that Artemis II's crew watched it shrink from a distant point of light to a horizon-filling wall of rock within a single mission. And yet, that short distance was enough to keep half the Moon completely hidden from every human being who ever lived. For the entire span of our species' existence. Until 1959, 1,600 miles is the width of the largest impact basin on that hidden side. Roughly the distance from New York to Denver, carved into solid rock by a single ancient collision. 5 miles is how deep some estimates place its floor, deep enough to swallow the tallest mountains on Earth without their peaks breaking the surface. 90 miles is how thick the crust becomes in some far-side regions, more than double the near-side average, a difference scientists still cannot fully explain with certainty. 4 billion years at minimum is how long the basin has existed, older than any rock ever found on the surface of Earth itself. Every one of these numbers describes the same small, quiet, grey world visible in the sky most nights, a world humans have looked at for the entirety of recorded history, without ever suspecting how strange half of it truly is. Let's think about the astronauts' return to Earth, because coming home carries its own quiet significance after an experience like this. Re-entry is violent by design, a spacecraft slamming into the atmosphere at tremendous speed, shedding energy as heat, protected by a heat shield engineered specifically to survive temperatures hot enough to vaporize most materials on Earth. For a crew that had just spent days near the Moon, watching Earth disappear and reappear from behind an ancient, silent hemisphere, the sudden return to blue sky, ocean water, and recovery teams waiting nearby, must have felt like stepping between two entirely different realities. One reality, total silence, ancient cratered rock, and a home planet reduced to nothing but empty sky where it should have been. The other, churning ocean water, recovery helicopters, radio chatter, camera crews, and the noisy, crowded, endlessly communicating civilization they had briefly, completely left behind. Few experiences in human history compress such a dramatic shift in perspective into so short a span of time. Days near an ancient, silent world, then hours later, back among the crowded noise of home, carrying with them data that will quietly shape lunar navigation for missions still years away from launching. Let's return, for a final time, to the anomaly that started this entire story. A tiny, measurable deviation in Orion's trajectory, recorded automatically by instruments never designed to hunt for lunar mysteries. Engineers on the ground, reviewing the data afterward, connected it immediately to the same buried structures scientists have been mapping since the 1960s. Structures tied to one of the oldest and largest impacts in the entire solar system. No dramatic alarm went off aboard the spacecraft. No astronaut felt anything unusual in the moment. The tug was far too small for any human body to sense. A fraction of ordinary gravity, noticeable only to instruments capable of measuring velocity, changes smaller than a snail's crawl. And yet, once identified, it connected instantly to a story stretching back over 4 billion years, through Soviet spacecraft and American orbiters, through Chinese rovers and European gravity satellites, all the way forward to 4 modern astronauts flying the most advanced crewed spacecraft ever built by NASA. A single small number, buried in navigation data, tying together the entire history of far-side exploration in one quiet, understated moment. Let's close, finally, by imagining what future missions might eventually reveal. Perhaps a seismometer network will finally record the far side's inner rumblings directly, confirming or overturning decades of modeling based only on near-side data. Perhaps a radio array, nestled inside one of the ancient shadowed craters near the pole, will finally detect the faint whisper of the earliest structures in the universe, a signal older than every star currently visible in the night sky. Perhaps astronauts will eventually stand directly above the buried anomaly Artemis II, merely brushed past from orbit, drilling into rock disturbed by a collision that happened before life existed anywhere on Earth. None of that has happened yet. For now, the far side remains mostly what it has always been since 1959 first proved it exists at all. Ancient, silent, only briefly visited. Still holding most of its oldest secrets exactly where they have sat since before there was anyone around to wonder about them. Let's take one more careful pass through the timeline, because seeing it laid out end to end makes the scale of this story easier to hold. 4.5 billion years ago, the Moon forms from the debris of a collision between early Earth and a Mars-sized object. A few 100 million years later, while still partially molten, some theory suggests a second smaller moon may have slowly merged into the far side, thickening its crust permanently. Around 4 billion years ago, during the chaotic late heavy bombardment, an object 60 to 170 miles wide slams into the far side, carving out the South Pole Aitken Basin, the largest confirmed impact scar in the solar system. The collision disturbs the Moon's young magnetic field, embedding unusually strong magnetized patches into the surrounding rock, patches that will still be detectable more than 4 billion years later. For the next several billion years, the Moon cools, its interior solidifies, its global magnetic field fades, and eventually disappears entirely, while the near side's lava plains form, filling ancient basins with dark, smooth basalt that will one day be visible from Earth as the familiar face in the sky. Roughly 300,000 years ago, give or take, anatomically modern humans first appear on Earth, and from the very beginning, they look up at a moon already ancient beyond comprehension. Already scarred by impacts and hidden asymmetries no one would understand for hundreds of thousands of years. In 1959, Luna 3 crosses behind the Moon and captures the first blurry photograph of the hidden hemisphere, ending humanity's total ignorance of the far side in a matter of hours. In the 1960s, American lunar orbiters mapping the far side in greater detail begin drifting mysteriously off course, leading to the discovery of mascons, dense buried masses distorting the Moon's gravity field. In 1969 through 1972, Apollo astronauts land exclusively on the near side, bringing home magnetized rock samples that prove the Moon once had an active magnetic field, though none of them ever set foot on the far side itself. In 2009, NASA deliberately crashes a spacecraft into a permanently shadowed polar crater, confirming the presence of water ice hidden in some of the coldest, darkest places in the solar system. In 2011, the Grail mission's twin spacecraft map the Moon's gravity field with unprecedented precision, revealing ring-shaped anomalies and confirming the scale of the mascons hidden beneath both hemispheres. In 2019, China's Chang'e 4 becomes the first spacecraft in history to soft land on the far side, using a dedicated relay satellite to bridge communication with Earth. And its rover begins uncovering strange layered material deep beneath the crater floor. And in 2026, Artemis II carries 4 astronauts around the far side for the first time since the Apollo era. Their onboard instruments, recording a faint gravitational tug from the same ancient basin, a final small data point added to a chain of discovery that began with a grainy photograph 65 years earlier. Laid out this way, end to end, the story stops being a single strange fact about a spacecraft's trajectory. It becomes something closer to a relay race spanning the entire history of spaceflight, each mission passing forward a slightly clearer piece of a mystery first glimpsed in 1959. A mystery still not fully solved today. Let's think, for a moment, about everyone who was never able to see this story unfold at all. Every human being who lived and died before 1959 looked up at the same moon we do tonight, and every single one of them believed, without exception, that they were looking at the whole thing. Emperors, philosophers, farmers, poets, generals, and children, across every culture in history, shared this same quiet, universal misunderstanding, simply because no one had ever had a reason to suspect otherwise. It is a strange kind of humility to sit with. The idea that for the overwhelming majority of human history, our entire species studied only half of its closest neighbor in space, and never once realized it. The far side was not a secret anyone was keeping. It was not hidden through any deliberate concealment. It was simply beyond reach, tucked behind the moon's own slow rotation, invisible not because anyone chose to hide it, but because the physics of tidal locking made it so. And now, in the span of just a few generations, spacecraft have photographed it, mapped its gravity, landed on its surface, and carried human beings past it directly. Watching its magnetic anomalies and buried mascons reveal themselves piece by piece. Let's think, too, about how much more remains completely unknown. For every mystery this story has covered tonight, the exact origin of the crust asymmetry, the precise nature of the buried mass beneath South Pole Aitken, the full extent of the water ice hidden in permanently shadowed craters. There are dozens more questions scientists have not yet even fully formulated, waiting on data that no mission has collected yet. What does the far side's deep interior actually look like, below the reach of any radar or gravity instrument flown so far? Are there other buried anomalies, smaller and quieter than South Pole Aitken, hidden beneath craters nobody has studied closely enough yet? What would a seismometer, sitting directly on the far side for the first time, actually record during a moonquake, filtered through crust twice as thick as anything Apollo ever measured? Every answered question about the far side seems to produce 2 or 3 new ones, a pattern common to almost every frontier of science, but especially vivid here. On a hidden hemisphere our species has only known existed for a little over 60 years. Let's end where the story of every mission eventually ends. Back on Earth, back among the noise, back beneath a sky that once again includes a small, familiar, fully visible moon. Tonight, when you look up and see that same pale disk hanging in the dark, remember that you are only ever seeing half the story. Behind it, facing away, permanently hidden from your eyes and mine, sits a scarred, ancient, magnetically strange hemisphere older than complex life on Earth, still quietly tugging at any spacecraft precise enough to notice. 4 astronauts flew past it in 2026, felt its faint gravitational whisper recorded in cold, quiet numbers on a screen, and came home to a world that had no idea, until they told it, just how strange the far side truly still is. Let's take a slower walk through the actual descent toward the far side, because the sequence of events during that pass deserves more attention than a single summary can give it. Roughly an hour before the spacecraft crossed behind the moon, mission controllers on the ground began running through a final checklist with the crew. Every system was verified. Navigation solutions were double-checked. The precise moment radio contact would be lost, and the precise moment it would return, had already been calculated months earlier, down to the second, based on the planned trajectory. As Orion approached the moon's leading edge, the lunar surface began to dominate the view from every window. Craters that had been abstract shapes on a map became towering, three-dimensional features, their shadows stretching for miles across the ancient terrain below. The crew watched the terminator line, the boundary between lunar day and lunar night, slide slowly across the surface beneath them, throwing long black shadows from crater rims that have not moved, structurally, in billions of years. Mission Control's final words before the blackout are always some version of the same routine phrase. Calm, almost procedural, masking the strangeness of what is about to happen. Then, exactly on schedule, the signal cut. Not gradually, not with static or fading strength, simply and completely, the way a light switches off. For the ground team, this moment always carries a particular tension, even when it happens exactly as predicted every single time. There is no way to speak to the crew during this window. There is no way to receive any data at all. Every system aboard Orion continues operating exactly as programmed, invisible to anyone on Earth, trusted entirely to prior engineering and testing. It is, in its own way, an act of faith repeated on every lunar mission, sending human beings into a communication void and trusting the machines surrounding them to keep functioning exactly as designed until they reappear on the other side. Let's think about what the crew themselves were doing during those specific minutes, because even routine procedures carry weight in this setting. Astronauts describe this window as unusually quiet compared to other phases of a mission. With no voice from Mission Control, checklists shift to internal crew coordination, calling out readings to each other directly, rather than relaying them to the ground. Cameras continue recording automatically, capturing footage that will not be reviewed by anyone until well after the spacecraft re-establishes contact. Some of that footage, according to those familiar with similar missions, tends to include long stretches of the crew simply looking outward, saying very little, taking in a view available to only a handful of human beings across the entire history of the species. It was somewhere in this window, according to the flight data reviewed afterward, that Orion's inertial measurement units recorded the trajectory deviation later tied to the buried mass beneath the South Pole Aitken Basin. The astronauts themselves had no way of noticing it in the moment. There was no alarm, no vibration, nothing perceptible to human senses. Only a machine, quietly and precisely tracking its own position, noting a discrepancy too small for any onboard system to flag as urgent, yet large enough for ground engineers to isolate clearly once the full dataset came back down to Earth. Let's consider, for a moment, how differently this same moment might unfold on a future mission specifically designed to study the anomaly rather than simply pass over it by chance. A dedicated science mission would likely carry more sensitive gravimeters, instruments built specifically to measure these kinds of subtle mass concentrations rather than relying on navigation systems repurposed after the fact. It might slow its trajectory deliberately over the South Pole Aitken Basin, trading fuel efficiency for a longer, more detailed pass directly above the anomaly. It might carry magnetometers tuned specifically to map the boundaries of the strongest swirls in far greater detail than existing orbital data allows. None of that describes Artemis II, whose primary purpose remained, first and always, the safety and success of its human crew. But the value of an unplanned discovery like this lies precisely in how it shapes the missions that follow. Engineers reviewing Artemis II's data are already discussing what a dedicated follow-up instrument package might look like, parked in a slower, lower orbit specifically over this one region, finally measuring in detail what a crude flyby only glimpsed by accident. Let's return to the broader question of why any of this matters beyond scientific curiosity, because that question deserves a direct answer. Understanding the moon's buried structure is not simply an academic exercise. Every future landing, especially those planned near the pole and near the South Pole Aitken Basin itself, will need extremely precise navigation to avoid hazards invisible from orbit, boulders, slopes, and shadowed pits that satellite imagery alone cannot always resolve in sufficient detail. Gravitational anomalies like the one Artemis II detected directly affect how spacecraft compute their position during descent, since even a tiny, unaccounted deviation can shift a landing site by a meaningful distance if left uncorrected. The same buried mass that nudged Orion's trajectory during a high-altitude flyby would nudge a lander's trajectory as well, and potentially by a more significant amount given the lower altitudes and more delicate maneuvering involved in an actual touchdown. In this very practical sense, every data point gathered about these anomalies, however incidental its discovery, directly improves the safety margins of future missions attempting to put human boots on that same ancient, scarred terrain. Science and safety, in this story, are not separate concerns. They are the same concern, approached from two different directions, both converging on the same buried, 4-billion-year-old mass, hiding beneath the moon's most extreme and least understood terrain. Let's talk about the engineers on the ground, because their role in this story rarely gets the attention it deserves. Behind every astronaut floating past the moon sits a much larger team, working in shifts around the clock, monitoring telemetry, verifying trajectories, and preparing contingency plans for problems that, ideally, never happen. For Artemis II, this team spanned multiple centers across the United States, coordinating with international partners, contributing hardware, and tracking support from stations spread across different continents. When the spacecraft disappeared behind the moon, these teams did not simply wait idly. They reviewed prior data, refined models for the exact moment signal should reacquire, and prepared to process the flood of telemetry that would arrive the instant contact resumed. It was this same team, hours later, poring over navigation logs long after the mission's dramatic moments had passed, who first noticed the tiny discrepancy in Orion's predicted versus actual trajectory. Not a dramatic discovery made in a moment of high tension, but a quiet one, made by someone comparing two columns of numbers late into a long shift, noticing they did not quite match. Science often looks like this from the inside. Less a lightning bolt of realization, more a patient, careful noticing that something ordinary looking is, on closer inspection, not quite as ordinary as expected. Let's think about how this discovery gets verified, because a single data point is never enough in serious science. Once the anomaly was flagged, the team cross-referenced it against existing gravity models built from Grail's much more detailed and precise measurements years earlier. The two datasets agreed, within the margins expected given the very different sensitivity of Orion's onboard instruments compared to a dedicated gravity mapping mission. This agreement mattered enormously. It meant Orion's tiny deviation was not some instrument glitch, some artifact of temperature variation or electronic noise, but a real physical effect caused by the same buried mass concentration Grail had already mapped in far greater detail. Independent confirmation, even approximate, is what separates a genuine scientific finding from a curious but ultimately meaningless blip in the data. In this case, two entirely different missions, built for entirely different purposes, separated by more than a decade, agreed on the same underlying physical reality hidden beneath the moon's far side crust. Let's consider what this kind of cross-mission agreement means for the broader picture of lunar science. No single mission, however sophisticated, tells the whole story of a world as complex and ancient as the moon. Each mission contributes one layer, one perspective, one type of measurement, and only by stacking these layers together, comparing them, checking them against each other, does a more complete picture slowly emerge. Lunar 3 contributed the first photograph. Lunar Orbiter contributed detailed imagery and the first hints of mascons. Apollo contributed physical samples and direct magnetic measurements. L-Cross contributed direct confirmation of water ice. Grail contributed precise, continuous gravity mapping across the entire surface. Chang 4 contributed a direct, on-the-ground look at subsurface layering inside the South Pole Aitken Basin itself. And Artemis II, almost by accident, contributed one more independent confirmation of an anomaly other missions had already begun to map. Gathered not by a dedicated science instrument, but by the ordinary navigation systems of a spacecraft carrying 4 human beings safely around the moon and home again. Let's pause on that word, safely, because it defines the entire purpose of the Artemis II mission from its very first design meeting. Every choice made in building Orion, from its heat shield to its life support systems to its navigation software, exists to answer one question above all others. Can this spacecraft bring its crew home alive through every phase of a lunar mission, without compromise? Scientific discovery, however valuable, was never the primary goal of this particular flight. It is important to hold both of these truths together without letting one diminish the other. Artemis II succeeded first and foremost as a test of human spaceflight safety, proving that a new generation of spacecraft could carry astronauts around the moon and return them home intact, using systems that will carry future crews all the way to the lunar surface itself. That the same mission also happened to brush against a mystery scientists have been chasing since 1959 is, in the truest sense, a bonus. An unplanned gift layered on top of an already historic achievement. Let's think about how rare this kind of overlap actually is in the history of exploration. Most scientific instruments are built with a specific question already in mind, sent specifically to answer it, funded and justified explicitly on the promise of what they might reveal. Artemis II's instruments were built to answer an entirely different question. One about engineering reliability and crew safety, not about buried lunar anomalies. That its ordinary safety systems happen to reveal something scientifically meaningful says less about deliberate design and more about how deeply interconnected spaceflight safety and lunar science have become. You cannot navigate precisely around the moon without, in some sense, measuring its gravity. You cannot measure its gravity precisely without eventually noticing the same buried anomalies scientists have spent decades trying to understand. Safety and science, in this particular corner of space exploration, turn out to be two names for the same careful, patient act of paying attention to exactly where a spacecraft actually is, compared to where it was expected to be. Let's return, finally and completely, to the 4 astronauts themselves. Because their names, their training, and their individual stories are in a sense secondary to the larger point this entire mission represents. They were selected, trained, and launched, not as scientists chasing a specific discovery, but as explorers testing whether humanity's next generation of spacecraft could carry people safely around our nearest neighbor in space. They completed that mission successfully, watched Earth vanish and reappear from behind an ancient cratered horizon, and returned home carrying data that will shape lunar exploration for decades to come. Some of it entirely by design, and a small, quiet fraction of it entirely by accident. That accidental fraction, a fractional deviation in a trajectory log, tied to a scar in the moon's crust older than life on Earth itself, is the thread this entire story has followed tonight. A thread stretching from a blurry Soviet photograph in 1959, through decades of drifting orbiters and painstaking gravity maps, through a historic robotic landing in 2019, all the way to a crewed spacecraft passing quietly overhead in 2026, carrying 4 people who felt nothing unusual at all, yet whose instruments quietly confirmed that one of the solar system's oldest and largest scars is still there, still buried, still shaping the path of anything precise enough to notice. Let's think about the instruments that will eventually replace guesswork with certainty, because several are already being designed right now. Proposals for a dedicated far-side geophysical network describe small, low-power landers each carrying a seismometer, a magnetometer, and a heat flow probe, distributed across several locations inside and around the South Pole Aitken Basin. Unlike Apollo's single cluster of instruments, confined entirely to the near side, this kind of network would finally allow scientists to triangulate signals, comparing how vibrations, magnetic readings, and subsurface temperature vary across the basin's enormous width. A moonquake recorded by only one station tells you it happened. A moonquake recorded by 4 or 5 stations, spread across hundreds of miles, tells you where it happened, how deep it originated, and how the surrounding material responded as the vibration passed through it. That kind of triangulated data does not yet exist anywhere on the far side. Every future mission, crewed or robotic, that lands equipment in this region adds one more potential node to a network that could, eventually, finally answer questions about the moon's deep interior that 6 decades of orbital imagery alone have never been able to resolve. Let's think too about how sample return missions could change this story entirely. Every rock ever studied from the moon in a laboratory on Earth came from the near side, collected either by Apollo astronauts or by robotic missions that until Chang 5 in 2020 had also only ever sampled the near side. Chang 6, launched in 2024, changed that, becoming the first mission in history to return physical samples from the lunar far side, drilling into the floor of a crater within the South Pole Aitken Basin itself, and carrying that material back to laboratories on Earth. Early analysis of these far-side samples has already revealed volcanic rock significantly older than equivalent samples from the near side, suggesting the far side's volcanic history unfolded on a different timeline entirely, adding yet another layer to the long list of ways these two hemispheres diverge from each other. Future sample return missions, potentially including material collected directly by human astronauts during an eventual crewed landing, could finally provide direct laboratory evidence about the exact age, composition, and origin of the anomalies Artemis II merely sensed from high orbit. Rocks, unlike gravity readings, can be dated precisely, analyzed atom by atom, and studied in ways no orbital instrument could ever match. Every one of these approaches, seismic networks, sample return, magnetic surveys, and crewed reconnaissance, chips away at the same fundamental mystery from a slightly different angle, slowly turning decades of indirect inference into direct physical evidence. Let's consider the sheer amount of patience this kind of science requires. 65 years have passed since Lunar 3 first proved the far side existed at all. In that time, only a handful of missions have specifically targeted the region in any detail, each separated from the last by years, sometimes decades, of funding decisions, engineering development, and international competition. Compare that to how quickly a single social media trend rises and disappears, and the scale of patience involved in lunar science becomes almost uncomfortable to sit with. Entire scientific careers, from graduate student to retirement, have unfolded entirely within the gap between one lunar mission and the next. Researchers spending decades studying data from a single flyby, waiting for a follow-up mission that might not launch until long after they have left the field entirely. Artemis II's astronauts, alive and active today, may very well live to see the eventual crewed landing near the South Pole Aitken Basin their own flight helped make possible. A landing that could finally place human boots directly above the buried anomaly their spacecraft merely brushed past from orbit. Or that landing may take another generation entirely, dependent on funding cycles, political will, and engineering challenges nobody can fully predict today. Either way, the far side will still be there, patient, ancient, and largely unchanged, exactly as it has been for over 4 billion years, waiting for whichever mission finally arrives next, to read the next few lines of its story. Let's think about how this story compares to other great scientific mysteries humanity has slowly chipped away at over similarly long timescales. The existence of the planet Neptune was first predicted mathematically, based on tiny, unexplained irregularities in the orbit of Uranus, decades before any telescope actually confirmed a planet sitting exactly where the mathematics said it should be. Continental drift was proposed as an idea in the early 20th century, dismissed by much of the scientific community for decades, until the discovery of seafloor spreading finally provided the physical mechanism nobody had previously been able to explain. Black holes were predicted by equations long before any telescope could directly image one, existing purely as a mathematical consequence of general relativity, until observational technology finally caught up, generations later. In every one of these cases, the pattern repeats itself. A subtle irregularity is noticed. A hypothesis is proposed to explain it. Decades pass while technology slowly develops the sensitivity required to test that hypothesis directly. Eventually, sometimes across multiple human lifetimes, confirmation arrives, transforming a strange anomaly into an accepted, foundational piece of scientific understanding. The far side's buried mass concentrations, magnetic swirls, and thickened crust are following exactly this same slow, patient arc, moving gradually from strange orbital drift noticed in the 1960s toward an increasingly detailed, increasingly confirmed picture, built piece by piece across 6 decades of careful, overlapping missions. Artemis II's brief, unplanned contribution fits neatly into this much larger pattern. One more data point in a chain of confirmation that began before most people alive today were even born. Let's think, finally, about what it means that this particular mystery sits so close to home. Neptune, black holes, and continental drift all describe things either impossibly distant or almost invisible in scale, phenomena most people will never personally witness or interact with in any direct way. The far side of the moon is different. It sits less than 250,000 miles away, visible in outline every single night from anywhere on Earth, close enough that ordinary commercial spacecraft, built by private companies rather than only national space agencies, have already begun flying paying customers on trips around it. The mystery this story has followed tonight is not hidden in some distant galaxy. Accessible only through faint light gathered by billion-dollar telescopes, it is hidden directly behind the same pale disk that has hung in Earth's sky since before our species existed. Close enough to touch with the right rocket. Hidden only by the simple, elegant physics of tidal locking. And by nothing more mysterious than the fact that nobody could see behind it until technology finally allowed us to look. Let's take one more moment before we close, because there is a quieter thread running underneath everything we have covered tonight. Every mission described in this story, from a fragile Soviet probe in 1959 to a modern crewed spacecraft in 2026, was built by people who never expected to personally witness the mystery fully resolved. Engineers who designed lunar orbiters' tracking systems in the 1960s did not live to see Grail's precise gravity maps decades later. Scientists who first proposed the giant impact origin of South Pole Aitken in the 1980s are, many of them, no longer alive to read the data returned by Chang 6's sample return mission. Each generation adds its careful piece, hands the puzzle forward, and steps aside, trusting that someone else, sometime later, will keep pulling the thread a little further. Artemis II's crew, 4 ordinary human beings trained for years to fly an extraordinary mission, now belong to that same long chain, having added their own small, quiet contribution to a mystery first glimpsed by people who died before any of them were born. Somewhere, decades from now, another mission will fly past that same ancient basin, carrying instruments none of us have designed yet, and add one more piece to a story that began the moment a violent, unnamed object struck the moon over 4 billion years ago, long before there was anyone at all to notice or to wonder why. Let's picture, one more time, exactly what those 4 astronauts saw as their orbit began to swing back around toward Earth. The terrain beneath them, dark and cratered moments earlier, began catching sunlight along its edge, the same slow Terminator line sliding across the ground it had crossed before. Only now in reverse. The horizon, still filled entirely with alien rock, began to feel less absolute, less permanent, as the minutes of blackout ticked steadily toward their calculated end. On board, checklists shifted subtly, preparing for reacquisition of signal, small procedural steps marking the return to contact with Earth after the longest stretch of total isolation any of them had ever experienced. Then, precisely on schedule, exactly as engineers on the ground had calculated months in advance, a signal reached back out across the shrinking gap between spacecraft and home. Telemetry began flowing again. Voices returned. And somewhere in that flood of returning data, buried among thousands of routine readings, sat the tiny trajectory deviation that would, days later, connect a modern crewed spacecraft to a scar in the moon's crust older than complex life itself. Let's sit for a moment longer with the sheer age of what we have been discussing tonight. 4 billion years is a number easy to say and almost impossible to truly feel. If you compressed the entire history of the moon into a single ordinary day, the impact that carved the South Pole Aitken Basin would have happened somewhere in the very first hour of that day, before almost anything else in this story had occurred at all. Human civilization, every pyramid, every war, every book ever written, would occupy only the final fraction of a second before midnight. Artemis II's brief flight past that ancient scar would not even register as a measurable sliver of time on a clock built to that scale. And yet, within that impossibly thin sliver, 4 human beings built machines precise enough to feel, faintly, the leftover gravitational signature of an event that happened during the very first hour of the moon's entire existence. That is, in the end, the strangest part of this whole story. Not the crater itself, not the buried mass, not the magnetic swirls or the ancient ice. It is the fact that a species so young, so recently arrived, has already built tools sensitive enough to reach back across nearly the entire history of the solar system and feel, however faintly, the echo of a collision that happened before there was anyone at all to witness it. Let's zoom out one final time, because the story of the far side is really a story about perspective. For nearly the entire history of our species, we assumed we knew what the moon looked like. We drew it in paintings. We named its dark patches after seas and calm and tranquility. We built entire mythologies around a face that was, in truth, only half the story. It took spaceflight to reveal that the other half existed at all. And it has taken more than 60 years of increasingly sophisticated missions to even begin explaining why that other half looks so different, feels so different, and behaves so differently under a spacecraft's instruments. Artemis II did not solve the mystery of the far side. No single mission could. But it added one more data point to a puzzle that stretches back to 1959, when a grainy Soviet photograph first proved that the smooth, familiar face we see every night is not the whole truth. It never was. Half of our nearest neighbor in space has spent 4.5 billion years facing away from us, accumulating scars, hiding dense fragments of ancient impacts, holding magnetic echoes of a core that died long ago, and sitting in a silence that human technology has never once disturbed. 4 astronauts flew past all of that in the year 2026, watched Earth vanish from their window, felt their spacecraft tug faintly against something buried and invisible, and came home changed by a few minutes spent somewhere no living person had gone before, 240,000 miles away, ancient beyond memory. Still, after all this time, largely unexplained. The moon we have always known, and the moon we have almost never seen, are the same small grey world. We are only now, slowly, beginning to understand how different its two faces truly are.